everyone, this is Erica, and I'm going to be doing a video on number 8 of Unit 3 Electric Potential. Alright, so if we read the question, it gives us two different figures right here and right here, and it asks us to first find the potential difference in both of these figures. And then it's going to ask us to find work done, and then which electric potential is higher or lower, and then if the charge was positive or negative. Alright, so the first thing I did on my piece of paper is I drew a figure of the problem. Right. So like I said, I drew a figure right here. And then the first part A asks us to find the potential difference in figure 1. So if you remember what potential difference the formula is it's KQ over R. So we just plug in the KQ over R for A and then for B. You can see for its A, it's 2 meters. And then for B, it's 1 meter. And then you just plug that into your calculator. K, remember, is 9 times 10 to the 9th power, which is negative 4,500 volts. We also do part 2, which is basically the same thing except for using the second finger. But since the orientation doesn't really matter, it's just mostly the charge, we can see that the answer is exactly the same as part 1. Alright, so part C asks us to find the work done moving a positive 10 nanocoulombs charge from A to B in figure 1 and then for figure 2. So already I'm going to assume that the answer for figure 1 and figure 2 is the same because we saw that the answer for A and B were the same also. So I'm just going to solve for one of them. I'm going to use A just because it makes my life simpler. And then part C. Work we know is change in electric potential times charge. So I just plug that in. 4,500 joules from part A and B. We can find that because instead of VA minus VB, it's VB minus VA, so that just flips over the sign. Times 10 to the negative 9th power. Sorry. Coulombs, which is work equals 45 times 10 to the negative 6 coulombs. Alright, so part D. So now we're going to find the work if it goes from infinity to point B instead of from A to B or B to A. We're going to find infinity. So we know that the work equals change in voltage, change in electric potential times charge, and we know that change in electric potential is KQ over R. However, we know that for the infinity, it's gonna end up to 0. So we're gonna just ignore that and just do it from B, which is KQ times R. Sorry, KQ times R. This is the charge that was given to us. We just plug that in a calculator. Here's what we get. And part E asks us if the electric potential is higher or lower as we move closer to charge Q. So because the R decreases, right? Potential is KQ over R. And as we can see, the smaller the R, which means closer it is to the charge, the larger answer we're going to get. Therefore, we know that as we move closer to charge Q, the electric potential will be higher. Right? Okay, part F. Is the potential energy of a positive test charge higher or lower as it moves closer to Q? So we know that it's going to become higher because as we already have a positive charge, right? And then we're going to have a test charge that's also positive approaching our originally their positive charge. As it gets closer, it's going to slow down because the force is larger, if you remember the force formula. And then instead, because we have a decrease in kinetic energy, we see that there's going to be an increase in potential energy due to the conservation of energy. Right? And then part G asks us how the answers from A through F would change if the charge was negative 1 coulombs, negative 1 times 10 to the 9th coulombs. And we can see that from here, if we flip from VA minus VB to VB minus VA, we can see that it just changed the different signs, right? So we can assume that from A to D, the answer would just flip signs. And then for E to F, the charge would be lower, the answer will be lower instead of higher. The reason why is if we had, for example, a positive and negative charge, this is for part F, by the way, and then negative charge is coming closer to the positive charge, then we're going to see an increase in kinetic energy, which means there would be a decrease in potential energy. All right, good luck on homework.